Welcome to this lecture series in coordinate geometry. In this lecture, we'll learn the formula for the distance between a point and a line, and let us recall what we need. So we need to know the meaning of the equation of a line. We need to know the distance formula, meaning the formula which gives us the distance between 2 points whose coordinates are known. Recall this basic fact that if you take the square root of x squared, you get the absolute value of x. So when we write this symbol, we mean the positive square root, and hence this is the absolute value of x. And lastly, we will use at one point the Cauchy-Schwarz inequality, which says that this is true for all real numbers alpha, x, beta, and y. If you haven't seen this before, you can prove it very easily just by taking squares of both sides and playing around a bit. At one point, you may need to use the AM-GM inequality. And if you are still not convinced, you can do a quick Google. This is the simplest version of the Cauchy-Schwarz inequality. You can easily find simple proofs of it online. All right. Here are some problems for practice. Yeah, now it should be visible. So these are some problems for practice. And now let us get started. Okay, so here is the main thing that we need to discuss. We are given a point P whose coordinates are x0 and y0, and we are given a line ax plus by plus c is 0. So since this is a line, it is already clear or already known that not both of a and b are 0. Okay, one of them can be 0, but not both of them. All right, so now we need to find a formula. We want to find a formula for this length. This is the perpendicular dropped from P to the line, and we want to find the length of this in terms of x0, y0, and a, b, and c. Okay. The proof we will give will assume that both a and b are non-zero, but the expression that we will find at the end works equally well, even if one of these were 0. Okay, so that is a simple exercise. The part where either a or b is 0, that is when it is, very easy to write down the distance between the point P and this line. So let's just focus on this. All right, so let's label the figure. What we have done is we have drawn the horizontal line passing through P, meaning the line whose slope is 0, and we have drawn the vertical line passing through P. All right, and let's label the figure. So the foot of the perpendicular be Q. This will be called B, and this will be called A. So the idea is we will find PQ by considering the area of this triangle. We can write down the area of this triangle in two ways. The first is when you think of this as the base and this as the height. The area of the triangle is half times base times height. Or you can take this as the base and write down the area as half times base times height. So this equality is what we already have. Half of BP times AP is half of AB times PQ. So if we can write down the expressions for these three things, we will automatically find the expression for that, and this is what we want. So to do that, we will find the coordinates of A, the coordinates of B, and proceed. So the coordinates of A are very easy to write down. Why? Because this is the vertical line, and therefore the abscissa of this is same as the abscissa of that, meaning the abscissa of this is x0. But once we know the abscissa of this, we will also know the ordinate, because the point A lies on this line. So the coordinates of A are the abscissa is x0 and the ordinate is this. Yep. And the coordinates of B, by similar reasoning, are, alright, these are the coordinates, and note that these are meaningful quantities because of our assumption that both A and B are non-zero. Okay. So, what is the length of BP? The length of BP is nothing but the difference between the abscissas of B and P with the absolute value sign. Or you can use the distance formula, but it's an overkill. So the length of BP is nothing but x naught plus that thing with the absolute value sign, which is equal to that. And what is the length of AP? So to cut the long story short, this will turn out to be that expression. Okay. So lastly, we will find what is the length of AB. Here we will use the distance formula properly. We know the coordinates of this, we know the coordinates of that. So just use the distance formula and we will get the square root of a horrible thing, or a not so horrible thing, it just looks horrible. So it is equal to this, and that is equal to this expression. So I kind of did two steps in one go. You first write down the algebraic expression of this by making A as the common denominator. So just do the algebra, you'll see that that is equal to this, and hence this is equal to the absolute value of this thing times the square root of that divided by that. So here we have played around with this expression to get this basically. Just verify, this is basic algebra. And now use this equation. We have the expressions of this, and that. So we will get the expression for PQ now. And that expression turns out to be equal to this. So this is the formula for the distance between the points P and Q, that is the length of the perpendicular dropped from P to the line that is given. So as we said, this works only, the proof works only when A is non-zero and B is non-zero, because at one point we are dividing by A and at another point we are dividing by B. But once you have obtained this formula, you can easily see that this works even if one of A or B is 0. So that is an exercise. So this is the general formula for the distance between a point and a line. The coordinates of the point are x0, y0, and the line is ax plus by plus c equals 0. Okay, so let's see one example where we use this. This is a problem. We need to, or the problem asks us to find the shortest intercept made by the family of lines given by this equation. I will explain what this means. On the circle whose equation is this. Now we do not need to know anything about circles. This is just a circle with center 5, 5, and radius 7. So that's this. If you don't know anything about circles, forget it. So we have a circle whose center is 5, 5 and radius is 7. And we have a family of lines where once you choose a value of A and a value of B, not both 0, you get a line. So amongst all lines that you can generate this way, what is the line that affords the shortest intercept? So once you get a line, either the line cuts the circle or it doesn't. If it does cut the circle, then you get this intercept. This is the intercept, and we are interested in the shortest intercept. If there is a line in this family which does not cut the circle at all, then our answer would be 0. The shortest intercept would then be 0. But if all lines happen to cut the circle, then it is more interesting. Then we need to work a little bit to find the shortest intercept. And the approach is to find the length of the largest perpendicular amongst all the lines that you can find in this family. Which one has greatest distance from the center? Why? Because once you know the distance between this point and this line, you can calculate the half of the intercept by using Pythagoras theorem in this triangle. So to find the shortest intercept, we need to find the largest distance. So I hope the scheme is clear, and let's proceed. So what is the distance between this guy and the center? As we just learned, the distance is, let's call the distance, let's say this is P, and this line is, it's some arbitrary line coming from A and B. So the distance would be, so the value of P is 5A plus 5B minus A plus 2B, absolute value, divided by this thing. That's what we just learned. So this is the distance between the center and the line, and we need to maximize this. So the expression is nothing but equal to that. All right, which is equal to this. Okay, and now by Cauchy-Schwarz inequality that we recalled, this is at most 4 square plus 3 square square root times square of this plus the square of that, but that is equal to 1. So let me not write anything. Right? This is alpha, this is x, this is beta, this is y in the notation that we recalled. So this turns out to be at most that, and hence it is at most 5. So what we have seen is that no matter what line you generate using a choice of A and B, you find that that line is at a distance of at most 5 from the center. So it definitely does cut the circle in 2 points. Okay, fine. Finally, you can achieve the distance of 5. The maximum distance you can possibly achieve is 5 given this calculation, but you can actually achieve the distance of 5 just by choosing A equals 4 and B equals 3. So if you choose these values of A and B, you do get a distance of 5, and hence 5 is the greatest possible distance between the center and any line coming from this recipe. And therefore, the shortest chord would be, I'll write something down and explain, of that length. So what happened? This length is 5. Make this triangle. This length is then hypotenuse square minus P square, meaning 5 square square root. So this is hypotenuse square, this is 5 square, difference and square root. So that is this length. And therefore the length of the intercept is twice of that. So this is your shortest possible intercept, and this number is twice of 49 minus 25 is 24. So root 24, which is 4 root 6. So that is the shortest intercept. Yeah, so very nice. And with that, I want to end this lecture. As usual, like, comment, share, subscribe, and I will see you next time.